Deep inside Siberia, thousands of kilometers from Ukraine, some of Russia's most valuable military aircraft were parked at bases believed to be protected by distance. But for 18 months, Ukraine had been preparing an attack that did not depend on long-range missiles, fighter jets, or drones crossing the entire Russian air defense network. Instead, small FPV drones were quietly transported into Russia, hidden inside wooden cabins carried by ordinary trucks, and positioned close to strategic airfields. When the signal arrived, the roofs opened, the drones rose into the sky, and targets once considered almost unreachable were suddenly only minutes away. The mission was called Operation Spiderweb, and Belaya airbase in Siberia became one of its most important targets. But how did Ukraine control these drones from so far away? How much damage was actually confirmed by satellite images? And which dramatic details remain part of an unverified battlefield reconstruction? Stay with Military Force as we examine the evidence, the technology, and the larger warning behind one of the most unusual drone operations of the war. Ukraine says Operation Spiderweb used 117 FPV drones, but this was not an independent swarm acting without people. President Volodymyr Zelensky said a matching number of operators took part, which suggests that every aircraft had a human pilot rather than one computer controlling the entire force. He also said the teams worked across several Russian regions and 3 time zones. The Security Service of Ukraine later repeated the figure, so 117 should be presented as Kyiv's official account, not as a number independently confirmed in full. That distinction matters because the command structure explains how the attack was organized. Later Ukrainian descriptions said pilots were assigned specific targets, which points to a planned series of separate missions instead of a loose cloud of machines. Each operator could study the location, recognize the assigned aircraft, and focus on a vulnerable area during the final approach. This method reduced confusion over the airfields and allowed several attacks to unfold at the same time. It also meant that the loss of one drone or one pilot's video feed would not automatically stop the others. The operation therefore combined mass with individual control, and that balance leads directly to the question of how commands cross such great distances. Reuters reported, citing a Ukrainian source, that the drones communicated through Russia's mobile telecommunications network. In simple terms, the operators did not need a normal radio link running directly from a nearby control position to each aircraft. Commands and video could move through cellular connections, much like data traveling between a phone and a distant server. This approach could place the pilots far from the launch areas, while the machines operated beyond the line of sight. It also turned part of Russia's civilian communications system into an unexpected channel for a military strike, although the exact network design remains classified. Images of the control interface offered another clue. Janes assessed that the pilots may have used Autopilot Mission Planner, a ground control program that can exchange telemetry through 3G or 4G networks and load routes made from selected waypoints. Telemetry can show position, direction, speed, battery status, and other flight data, while the planned route gives the aircraft a basic path before human guidance becomes necessary. The software is widely available, but its use in this operation would not make the mission simple. Reliable connections, secure access, accurate maps, and careful timing would still be required for many pilots to work together. Mission Planner can also support automated flight towards stored waypoints, but that does not prove every Spiderweb drone could find and destroy an aircraft alone after losing contact. A machine may continue along a saved route when the signal disappears, return to a set point, or hold its course for a limited period. Target recognition is a separate challenge because a drone must identify the correct object, adjust to changing conditions, and choose a precise impact point. Public evidence has not shown that all 117 machines possess that complete level of autonomy. Claims that the entire force could independently finish the attack should therefore remain treated as possible, not established. Even with those limits, the control system offered 4 clear tactical advantages. It reduced dependence on a short-range radio link, extended command beyond the horizon, used infrastructure already spread across Russian territory, and allowed operators to remain farther from the target area. This made it harder to locate the pilots through ordinary direction finding near the bases. It also shortened the visible part of the operation because the drones only became an air defense problem after launch, while much of the command network remained outside the immediate battlefield. Yet communications technology was only half of Spiderweb. The other half was placing each drone close enough to reach the bomber it had been assigned. Belaya mattered because it was not a forward airfield exposed to the Ukrainian front. It sits in Russia's Irkutsk region in eastern Siberia, more than 4,000 kilometers from Ukraine. The base supports Moscow's long-range aviation force and had hosted two 22 M3 bombers, while two 95 MS aircraft were present when Operation Spiderweb began. Russia has used these planes to launch long-range attacks, and the two 95 MS can carry cruise missiles far beyond the front. That made Belaya a military asset and symbol of the safety Russia believed distance could provide. The strongest evidence came from space, rather than from statements issued by either government. Planet Labs. Images taken after the strike showed blackened ground, aircraft wreckage, and scattered debris across the parking area beside the runway. At least 3 Tu-95 bombers and 4 Tu-22 aircraft appeared destroyed, bringing the visible total at Belaya to 7. Other planes nearby seemed untouched, which made the damage pattern easier to identify. These pictures did not confirm every Ukrainian claim, but they proved that the attack reached aircraft deep inside Russia and caused more than minor surface damage. A cautious standard still supports the conclusion that Belaya suffered a serious loss. Reuters reviewed radar satellite imagery and consulted open-source specialists who identified the apparent remains of at least 2 destroyed Tu-22 bombers. The same material, combined with verified attack videos, indicated that 4 Tu-95s had been destroyed or badly damaged. Experts placed the number of bombers destroyed or severely damaged there between 6 and 8. That range is close to the AP reading, although the methods were not identical. The evidence therefore supports heavy damage, even while the final count remains open. Counting aircraft losses from satellite pictures is harder than it appears. A burned plane may be beyond repair, but fire marks alone do not always show whether the airframe can be restored. Smoke, clouds, shadows, image angle, and resolution can hide important details. Radar satellites can see through cloud cover, yet their pictures are grainier than optical images. Wreckage may also be moved before a later satellite passes overhead, while damaged parts can remain difficult to separate from debris. For that reason, hit, damaged, badly damaged, and destroyed should not be treated as equal terms. This caution becomes essential when comparing independent assessments with wartime claims. The wider Ukrainian figure was much larger than the damage visible at one base. Kyiv said 41 Russian aircraft were struck during the full operation, but 2 United States officials told Reuters that up to 20 planes were hit and around 10 were destroyed across all targeted sites. Reuters could not independently confirm either estimate. Belaya offers a firmer picture because commercial imagery captured clear wreckage in known parking positions. Even there, analysts used ranges rather than one final number. This does not reduce the importance of the attack. It shows why a careful report should separate confirmed physical evidence from national claims made during war. That distinction explains why the type of aircraft lost matters as much as the total. Satellite images can confirm destruction, but they cannot explain every minute of a battle. That rule is important at Belaya. The pictures show burned aircraft, damaged parking areas, and scattered debris, yet they do not reveal which drone arrived first, how each radar reacted, or what decisions Russian crews made under pressure. Evidence from space proves that serious damage occurred, but it does not prove a complete tactical timeline. The detailed story should therefore be treated as a reconstruction rather than a fully verified record, and that difference shapes how every claim must be presented. The reconstruction describes a carefully timed attack involving 23 drones. It says 14 OSA quadcopters were hidden inside a cabin about 7 kilometers from the base, while 9 fixed-wing drones called Darts Norda were prepared at a second site around 35 kilometers away. According to this version, the first group targeted a Pantsir system and the control tower. Later waves then moved toward two 22M3 bombers, while the final formation approached two 95MS aircraft from another direction. Tor missiles, electronic warfare teams, and ground security forces were said to have stopped several attackers. The sequence is clear and dramatic, but most of those details remain part of the reconstruction itself. One part of the story does have stronger support. Images and location analysis identified a truck linked to the attack on the P255 highway, about 7 kilometers from Belaya. That finding supports the central method of Operation Spiderweb. Short-range drones were transported close to the airfield and launched from inside Russian territory. It also explains why distance failed to protect the base. However, the truck's location does not prove that 14 OSA drones came from one cabin, that a second launch team waited 35 kilometers away, or that every wave followed the exact order described. The launch method is supported, but the full battle sequence is not. Several details remain outside the confirmed public record. There is still no firm evidence that exactly 23 drones attacked Belaya, that 2 different models were used there, or that a type called Darts Norda took part. OSA has appeared in later discussions linked to Spiderweb, but that does not confirm the stated number, payload, route, or target list. Public material also does not show the precise order of attacks against Pantsir, the tower, Tu-22M3S, and Tu-95MS bombers. It does not reveal how many targets each air defense system could engage at that moment, what individual crews decided, or exactly when jamming affected any video feed. A careful script should therefore use clear phrases such as "one possible scenario," the reconstruction suggests, and "public evidence has not been confirmed." This language does not weaken the analysis. It shows the audience where fact ends and informed interpretation begins. Satellite images reveal the result, while verified videos and geolocated pictures can show parts of the approach. They still cannot place every drone on a precise path or explain every defensive reaction inside the base. Clear wording protects the credibility of the report and allows the tactical model to be examined without turning assumptions into facts. Even as a hypothesis, the multi-wave design explains a sound military principle. An opening group can draw radar attention, force air defenses to fire, and push crews to focus on one side of an airfield. Operation Spiderweb did not make distance useless, but it showed that distance can no longer guarantee safety. Before the strike, Belaya benefited from its position inside Siberia, beyond the reach of Western weapons and far from the Ukrainian border. Any air attack would normally face a long journey, early radar detection, and chances for interception. That confidence depended on one assumption: the threat would begin far away. Spiderweb challenged it by moving the starting line closer. The drones did not cross thousands of kilometers of defended airspace. Trucks carried them along roads and brought the launch systems near bases. Most of the distance was covered as transport, not as an air operation. Russian sensors only faced the threat after the roofs opened and the aircraft took off near their targets. Warning time may have fallen from hours to minutes, leaving commanders less space to identify, track, and engage each object. That change pressured the defensive layer. Traditional air defense was not designed to solve every part of this problem. Long-range radars are strongest when searching for aircraft, missiles, or larger drones approaching from outside a protected zone. Small quadcopters flying low can blend with buildings, trees, vehicles, and background noise. Short-range systems can respond, but they cannot watch every direction equally without reliable warning. Electronic warfare also needs time to detect the control method, find the frequencies, and interfere before impact. When launch sites appear close to the perimeter, even advanced weapons may react too late. The weakness therefore extends beyond missiles and radar. Russia must inspect cargo vehicles, watch storage sites, track unusual cabins, and control roads surrounding sensitive facilities. Security agencies may also examine SIM cards, mobile data patterns, remote control equipment, and deliveries linked to temporary companies. Aircraft left in open parking areas remain exposed because a charge can reach fuel, wiring, or other vulnerable parts. Hardened shelters, wider security zones, and stronger local surveillance may now matter as much as another launcher beside the runway. That lesson reaches beyond Russia. The United States and NATO operate networks of bases, ports, warehouses, and airfields across open societies. An installation may have strong radar coverage and still remain vulnerable to cheap drones launched from a truck outside its fence. Counterintelligence, supply chain checks, police cooperation, communications monitoring, and counter-drone defenses must work as one system. Spiderweb showed asymmetric warfare because a smaller force used low-cost technology and planning to threaten rare platforms worth far more. The same logic could spread elsewhere. The operation must still be judged with balance. It did not destroy Russia's entire long-range aviation force, and it did not remove Moscow's nuclear deterrent, which also rests on land-based missiles and submarines. Yet it forced Russia to consider dispersing aircraft, building shelters, tightening domestic controls, and spending more to protect rear areas. The central issue is not how far the drones flew. Ukraine changed where the attack began, and that shift prepares the ground for measuring Spiderweb's broader strategic result. Ukraine achieved a confirmed strategic success with Operation Spiderweb, but the exact scale remains disputed. Kyiv openly claimed responsibility and explained that drones had been moved into Russia before being launched near military airfields. Moscow later acknowledged attacks and fires at bases in the Irkutsk and Murmansk regions, although Russian statements described the damage in limited terms. Independent satellite images then showed burned aircraft and wreckage at Belaya, proving that the operation reached valuable targets. That evidence creates a firm starting point, but the numbers still require careful separation. This three-level chain of claims, admissions, and visual proof is stronger than any single wartime statement, yet it still cannot settle every disputed aircraft count. Ukraine's security service said 41 aircraft were destroyed, while President Volodymyr Zelensky initially stated that more than 40 strategic planes had been affected. A later American assessment was much lower, estimating that about 20 aircraft were hit and roughly 10 were destroyed across the full operation. At Belaya alone, satellite analysis identified 7 bombers that appeared burned beyond use. These figures describe different standards because affected, hit, damaged, and destroyed are not equal. The responsible conclusion is that Ukraine caused major losses, while the claim of 41 destroyed aircraft remains unconfirmed. The remaining uncertainty therefore concerns scale, not whether the strike succeeded militarily. The attack did not end Russia's ability to conduct long-range strikes. Moscow still operates other bombers, and it can launch cruise missiles from aircraft, ships, submarines, and ground-based systems. Yet the loss of rare Tu-95MS and Tu-22M3 airframes reduces the reserve available for future missions. Surviving planes may need to fly more often, which increases maintenance pressure and shortens the time available for repairs. Russia may also move aircraft between more locations, but wider dispersal creates longer supply routes, additional security demands, and greater strain on trained crews. The deeper impact was psychological and doctrinal. Airfields far from the border had been treated as protected rear areas, but Spiderweb showed that a hidden launch platform could appear near the runway itself. Russia must now consider roads, warehouses, commercial vehicles, mobile networks, and nearby settlements as part of base defense. Aircraft may need to be separated, placed inside hardened shelters, or surrounded by stronger local surveillance. This means protection can no longer begin at the airfield fence, because the threat may already be inside the surrounding transport system. Spiderweb also changed the cost of defending strategic assets. Cheap drones did not replace bombers, missiles, or conventional air power, and they did not remove Russia's nuclear deterrent. Their effect came from forcing a much larger military to spend more on inspections, shelters, electronic security, police work, and short-range protection across many sites. Every new measure consumes money, personnel, and time that cannot be used elsewhere. The operation therefore proved something narrower, but still powerful. Low-cost systems can force a major power to defend assets that once seemed beyond reach, and that is where its wider strategic meaning begins. Operation Spiderweb did not destroy Russia's entire strategic bomber force, and it did not end Moscow's ability to launch long-range strikes against Ukraine. But it changed the way military planners must think about distance, warning time, and base security. Ukraine did not overcome more than 4,000 kilometers with one extraordinary drone. It overcame that distance through secrecy, transport, mobile communications, and careful preparation. The weapons were moved close to their targets before the air attack began, which meant the most dangerous part of the mission happened on roads rather than in the sky. Kyiv says 117 drones were used, while satellite images confirm that several Tu-95 and Tu-22 aircraft were destroyed at Belaya. The claim that 41 planes were struck remains higher than later American estimates, and many details about each launch team, drone type, and defensive response are still unverified. Even so, the confirmed damage is enough to show that the operation was more than a symbolic raid. The deeper lesson is that a defense system built to watch distant borders can still be surprised by a threat launched nearby. Russia must now protect not only the air above its bases, but also the roads, warehouses, vehicles, mobile networks, and civilian areas around them. The central question is no longer only how to shoot down a drone after takeoff. It is how to stop the attack before the truck reaches the launch point. Subscribe to Military Force for clear analysis of the weapons, strategies, and political decisions shaping modern war.